Have Milos Kukulovic and Andrea Guccio, who are presenting a GPT-generated text detection problems and solutions in the scientific publishing, which is going to be more and more challenging every time. Milos has a PhD in computer science, and he's an IT executive, certified project and product manager oriented to complex assignments with 12 years working experience in the academic publishing business. And Andrea Guccio is an artificial intelligence tech leader at MDPI and founder and organizer of Python Biela Group. So let's give a big round of applause for both of them.
Thank you very much. Hope you can hear the mic, right? Okay, good. So thank you very much, guys, for being here. I'm Milos, Andrea Guccio, my colleague here. We both come from MDPI, and today we'll present you some challenges and solutions we have in academic publishing to detect GPT-generated text. That is, since the release of ChatGPT, becoming a very, very hot topic and very critical in all kind of area, especially in academia and publishing. So we were greatly introduced. I will not spend a lot of time on that slide. So basically, this is the data or the information you just got before. Who we are and what we do at MDPI. So a very, very short slide about the company and what we do there. We are an open access publisher at MDPI, meaning that we publish free to access content and ownership remains with authors. And we do have over 400 journals in all kind of fields with over 1 million of articles published since 1996. So it's a big publishing company with a lot of data, a lot of text that makes the challenge even greater and more important for us. So one part of the company is the AI team that both me and Andrea are working for. There are some other very nice colleagues in there. We do develop internal and external tools, meaning we have tools for internal usages, like a peer reviewer finder for our submissions, etc. But we also work on tools that we then put publicly available on our website that is used mainly by scientists. So we do mainly work with NLP because we do have mostly to do with text in there. So AI-generated content is there since some time now, creating a lot of polemics, a lot of discussions, and academia and publishing is not left aside of that movement in there. So we do have cases where parts or full articles we do receive, we need to process and to publish or reject afterwards, are written by AI tools. So I'm super glad that we had this ethics session this morning because we are exactly dealing with the same issues where we are yet not sure ethically if it's allowed to use such tools in scientific publishing and also how to use them. So we have examples where authors were citing ChatGPT as being one of the authors of co-authors of the papers, which sounds funny, but it's reality. We came up with a document for COPE, that is the Committee of Publication Ethics, that says that we cannot list those AI generative models as co-authors, which makes sense or not. And also, whenever we use them, it needs to be fully and explicitly written on how those tools were used. So this is why some time ago we came to the idea to explore what do we have currently in the market to detect AI-generated text in scientific literature. And also, Andrea Guccio will follow up with some slides on how we evaluate those, what were the results, and what is what we are doing at the moment at MDPI to cope with this kind of problem. So, Andrea, the stage is yours.
Okay, thank you, Milos. So this is basically what happened a year ago and a few months ago. So you know that there was this tool called Galactica that a lot of people started using, but it was like a failure. And now what's happening right now is that everyone is using large language models, especially GPT, and to generate text. Okay, so we are using like models that are not meant to be and created for science, but for more general tasks to generate part of the contents. As Miller said, like part of the papers, reviews, a lot of things that running in NLP in general in science. So this is what is happening right now, and we feel this problem very much. Okay, the question, of course, is how to solve this problem, okay? We need to solve this problem. Of course, we need like an automated alerting tools to spot this content. We received at least 2,000 new submissions to check every day in MDPI. So of course, it's really complicated to have internal experts in every field to check the content manually and to check all the information manually. It's quite impossible. And of course, if an article came out with a lot of text generated by AI, it's really expensive and complicated to retract this article back, okay? So of course, we need some generative AI detection system, and we start working on this field since a few months. And of course, we need like a large content analysis and detection, because the text is really, really long. And we need the possibility to scan and analyze different type of contents, because now we are speaking about NLP, but there are also images that are generated by AI and are inside the papers, okay? Also, as I said, reviews, comments, different types of text also. And we need to combine this system with other ethical tools and checks. We have a software suite that we are developing to solve other ethical issues in science. So we need to combine these tools with these AI systems to detect the text. And of course, it's really important to, this tool need to be controlled by humans, of course, to avoid bias, false positive, so you need also the control of the humans of the evaluation. Of course, we are trying to beat the last model available in the market, Llama V2, GPT-4, then I know GPT-5 or whatever. On the technical side, of course, this brings a lot of challenges for us. I don't know if someone of you are AI ops or machine learning ops working in this field. So it's really complicated now to fine-tune large language models. You need a lot of resources. And of course, we cannot rely on commercial application only. I want really to thank Hugging Face, Meta, and of course, you that you are maintaining a lot of open source packages. Without you, we are lost. Of course, this is the preliminary generative AI tech stack that we are trying to create in MDPI, because of course, these challenges of models bring a lot of challenges in architecture also. So we need to adapt our architecture, our models, our tools to be ready for AI. And of course, there is something that we are talking about and thinking about. It's the technical and algorithm depth in generative AI and NLP in general that we are not considering at all, I think, at the moment. Regarding the models becoming old, there are a lot of problems, and of course, there are technical problems. So the model needs to be there for a long time also and scan a lot of text. Of course, as we said this morning, there is the EU AI Act that is going on, and we need to adapt also the models and the system we are building, also this one, to this new regulation act, okay, to be compliant also to what's happening in the world. Lots of challenges. GPT detection problem. So let's go deeper into the problem. As you can see here, this is the post of OpenAI that claimed that the classifier that they were building, it's not working. It's not fully reliable. So basically, OpenAI, they stopped working on a classifier to detect the content generated by their algorithms because it's too broad, okay, the field. The field is too broad. If you need like a detector for identify general content and general text in every situation, it's really complicated, okay? And of course, so we said, okay, OpenAI cannot make it. What can we do? How can we solve this problem? And we identified 4 possible solutions that we are trying right now, especially one. The last one, it's what we are using right now. And I will go a little bit deep into these kind of solutions. We don't have time to go into a lot of details, but of course, ask us if you need more information. So watermarking, probability analysis, classification algorithm, and there is new method called adversarial learning paraphrasing detection. Of course, in the world, there are a lot of new startups and commercial solutions that we evaluate. We evaluate basically all the tools available in the market. And we find a lot of problems like aggressive pricing, high cost. It's not very clear the privacy regulation and third-party plugins that are there. And of course, we didn't find like a custom and fine-tuned solutions with good cost also. So that's why we decided to investigate a little bit more on the problem. Watermarking. Okay, watermarking is really simple, but it's need to be implemented top-down, so on the model side. It's the way to generate a set of green tokens before the word is generated. Okay, so you can identify which token is generated or not, and you can identify the model. Then there is the likelihood way. It's basically like you take the likelihood associated to the different perturbations, and basically you estimate the probability that the text come from the LLMs. What is the problem of this technique? It's really interesting, but the problem is that you need a lot of heavy computation to run this solution. And of course, so far, all the literature is speaking, and it's tested only on simple models like GPT-2 and not like GPT-4, Llama, or new approaches. There is a new interesting method that we are looking for. It's called adversarial learning paraphrasing detector. So basically, it's you collect a feedback. You have two things, a detector and a paraphraser, and you basically collect the feedback from the detector to update a paraphraser. The paraphraser, what it's doing, is perturbing the text. So basically, you're using like an adversarial attack to play two models against each other and collect feedback, and at the end, you have a model that is capable to identify this content. Okay, as you can see here, what is the problem? It's quite new and not very well tested. It's really promising. Of course, you need a lot of work to create two models and go in production with both and maintain these two models. Okay, what we're doing right now, basically, we are using this technique that is, of course, it's simple, and I would say simple is always a good solution, probably. So we are training a classification and discrimination. We call this classic detector. Basically, it's a classification model, okay, based on transformers. To distinguish between human and generated text. Of course, we are training in a specific context, okay? So we take a large language models, we generate a perturbated data set, for now only in our corpus, but with title and abstract, because you know there are a lot of limitation of 512 tokens in the models, depends on the architecture that you're using. Basically, we are training this classifier based on some open source, but also trained models by us. Like, for example, Distilbert. We're using Spectre V2. It's a good model for Allen AI. And also, we have our model, then one of our colleagues trained. It's called Silitbert, that we are using with our corpus. And of course, also we are trying to do some model interpretability with CHAP and other systems to check the performances of this classifier, not only using metrics to check if it's good or not. Of course, this problem is really interesting and really promising. What is the problem is that, of course, it's a classifier model. So every time that a new model came out, you need to take this model, perturbate the data set, train again, and you have a lot of explainability problem, calibration, data drift, so it's not like a perfect solution. That's why it is still an open problem, okay? Okay. It's okay, the time? Okay. We are going to the conclusion because we don't have a lot of time, but if you have any question, I can go briefly to the points and talk about a little bit of the methodology. So what we are doing right now, on the model side, we are collecting a lot of data, and we are creating a new data collection, not only based on the general content, because science, you know, it's really broad, no? So we are trying to differentiate the data set for topic also, like, I don't know, medicine, social science, and whatever. And to try also if there are differences between the models and the results that we have. We are trying to generate a perturbed data collection with different commercial and open source large language models. And this is a problem because we need a big GPU. And of course, we need to expand this model to reason also with full text articles. It is an open call. So we are trying to reason, we try to expand the number of tokens that this model can analyze and use to have like more results also, and not applying like a for loop to all the content. And of course, we are testing also different methodologies that you saw here, always searching for a new solution in the research. The field is really expanding. And on the infrastructure side also, because we need to go in production with these models, we have new GPUs coming because Llama V2 and these kind of models are really a big beasts. And we are improving also the AI operations infrastructure with a lot of parameter optimization and retraining. There's a lot of going on in this field. Of course, we are migrating to Quadrant as a vector database. It's really promising, and I want to please also the creators of and the community about this beautiful vector database. Okay, some final considerations. It's a difficult task, okay? It's really complicated, but we saw that work on specific use cases like science and maybe splitting by topic, like, I don't know, medicine, pharmaceutical part, social science, history, whatever, we can solve this problem using, for now, a classification and discrimination algorithm. Of course, we need to start using full text model, not only in our field, but also in other architectures. Full text, it's complicated because you can have like a book or you can have a paper, so it depends on the length. No? But for sure, we need to expand a little bit the number of tokens that we can use. I show you very, very briefly, unfortunately, but we can talk together about 4 different methods, pros and cons. For us, if someone is able to create like a watermarking solution and tag the model, so we'll be able on the top to see if this content is generated by an algorithm or not. It's the best solution, but it's not happening in the world right now, especially in commercials. And of course, it's a problem with a lot of there's a lot of problems with commercial solutions, as we said, like the price, the privacy of the data, the scalability, the customization. And of course, for now, it's tested on our corpus exclusively right now. We are trying also to use some science and open data collections to evaluate the classifier, so we can share also more results and more informations. Some infrastructure considerations only, also, like large language models need a powerful ecosystem, we know that. And of course, going in production with large language model, it's really, 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 really complicated right now and require a lot of resources. There is a lot of tech and algorithm depth. So as an MLOps engineer or AI engineers, always we are focusing on building something that works right now, but we are not focusing to maybe support these models and this system for a long period and a long time, like, I don't know, years or, I don't know, also months sometimes. And of course, we need to solve this problem. It's an open call. We are cooperating also with a lot of different organizations to try to solve this problem. It's really a hot topic, and we need to solve this problem here. Thank you. Sorry, I took a little bit of time.
Thank you very much for this nice talk. We don't have time for a lot of questions, but 1 or maybe 2 before the lunch break. Okay.
So the adversarial one that you named, the more complex one?
Oh, yes.
So are they like kind of gen-based? Is that kind of the framework behind them?
No, there is no framework behind them from now. By the way, in the slides, there are references of the papers that we are citing here. So you can, if you have the slide, you can check everything, also the papers and stuff. No, there is no framework there for now. We are trying to create something from scratch.
Oh, so it's really a theoretical framework so far already?
Yes, it's something that we are building right now.
how are you ensuring the purity of your sample data going forward now?
I'm sorry?
How are you ensuring the purity of your sample data? So you're not, like, how do you select the validation data going forward now? Because you can't be quite sure that the papers that are publicized now are not generated, right?
That's a good question. That's a good question. The first solution is to select only corpus that is before a certain period of time, like, I don't know, 2023, okay? The second solution also that we are using for all our algorithm and all our approach is to have always a human evaluation of the articles and the content, but also the output of the model. So before going in production, we always have like a human evaluation step to check the performances and everything that can help on the performance. But yes, this is the two main reasons. And also, as I said, splitting by topic. Of course, in this kind of architectures, more corpus you have, it's less prone to have bias, I think, but depends also on the content that you have. But this is, yes, this is the solutions.
One question for, do you also process the bibliography in a paper? Because for a long time, GPT was just doing fake references, so it was kind of a hallmark. I don't know if it's still the case.
Yes, as I said before, we start developing this system, but also we want to integrate this system with an ethical suite that we are building to check other problems. Like one of the problems is this one, no? To have like fake references or not meaningful references also. And we're using some models to do that based on similarity between vectors, basically. We extract the informations, like we take the DOI, with the DOI we extract the articles, and if there are a lot of distance, we say that the reference is not valid. It's complicated right now also to analyze all the science and all the references because you have to search all around the web. So imagine that you have, I don't know, 30 references for a single article, you have to go around and check everything. We are trying to solve also these problems here. As I said, ethical problems, it's complicated to solve. We are trying to do our best. A little bit of improvement in this field makes a lot of advancement, and you can have a lot of things, actually, with a few improvements. Yes.
Can I just add?
Yes, of course.
Just to complete the answer. We have another colleague at MDPI that is working on reference manipulation and parsing from articles, but it's outside of ChatGPT detection. We have our own database that you can find on scility.net website, which covers normally all the articles published in science. So what Andrea said, we try to identify the references with real articles there. If the match is not possible, then we alert the editor that needs to manually check if the reference is real or it was like fakely generated by ChatGPT, for example. But it's not an easy topic again.
It's not, yes.
That takes energy and time.
I guess we could be talking about this for hours, but it's lunchtime, so let's give a big round of applause to our speakers once again. Thank you.